Okay, so today we are going to learn about speed time graph. So the first learning standard is how to draw a speed time graph. Okay, basically drawing speed time graph is just the same as drawing the distance time graph. What we need is either the speed time table or the equation that represent the relationship between speed and time. Okay, it's just the same like what we did for the distance time graph, so I don't think we need to repeat the same thing all over again. So the difference is just on the axis. The vertical axis is now the speed, and the horizontal axis still remains the same, which is the time. So now the gradient of the graph represents the rate of change of speed with respect to time. Is the thing that we call acceleration. Okay, so before this, the gradient is the speed. Now the gradient is the acceleration. Okay, so that's the difference between distance time graph and the speed time graph. Okay, so let's look at example 10 here. Okay, example 10, given the data and then asking you to draw a speed time graph. Again, drawing graph means you have to plot the graph in details, and you must use ruler, and here are the steps. Okay, so choose appropriate scales, plot the points, and then in the end join all the plotted points using a ruler. Okay, don't forget the axis, the origin, and all the basic things that you need to have for a graph. Okay, so next, the relationship between the area under a speed time graph and the distance traveled. So we move to the next learning standard. Okay, so the learning standard here. So how do we determine the distance from the speed time graph? Okay, so here new speed time graph and the distance time graph. Okay, let me do the comparison. Here is your distance time graph, and let's say we have a line here. So the speed, the gradient is the speed. Okay, when speed become your vertical axis in speed time graph, okay, so the gradient here is the acceleration. Okay, so from the distance time graph we can determine the speed of the motion, and then from the speed time graph we can determine the acceleration of the motion. Okay, do you understand? Okay, good. So how about the area under the graph? Okay, so here I have a straight line. So if I were to draw the third line here, so we will have a region down here. So that region, it has an area. So the area under the graph, under the speed time graph, area under the speed time graph is equal to the distance. Okay, the distance traveled. Okay, so this is the new thing that you learn in this subtopic. Okay, area under the graph equals to the distance traveled. So basically You have to digest this thing in your mind. Okay, so let me give you some example. Okay, let's say we have a graph here. Here the speed and the time in hours. Speed in kilometer per hour. And then trending. Here is 5. Up here is 10. Down here is 0. And here is 4/5. How do you calculate the distance traveled for this graph? So the distance traveled is basically the area under the graph. So what shape is that? It is a trapezium. So the distance, okay, so the distance equals to the area of the trapezium (1/2) times 5 plus 10 times the height 4/5. Okay, 15. 1, 3, 1, 2. 3 times 2 equals to 6 kilometer, of course. Okay, so the distance is equal to 6 kilometer for this graph. Okay. Okay, next, how do you interpret speed time graph? Okay, interpret speed time graph. Okay, let me sketch a simple graph. So here we have the time in second and the speed in meter per second. Okay, 0 here. See, I have this shape. Okay, here I have T1, here I have T2, and here I have T3, and here let's say U speed, and up here is V speed. Okay, what can we say? Here we have a uniform speed. Okay, the speed doesn't change from T1 to T2. Okay, from 0 to T1 the speed increases, so we would say this part here as acceleration. Okay, and down here when it's going down we call that object has deceleration. Deceleration. Okay, so what does it mean by acceleration? So acceleration is equals to the change of speed final speed minus initial speed divided by the change in time. Okay. The area under the graph here. Okay, let's use in here. Okay, that region, the area of trapezium A. Okay, that trapezium A is the area under the graph that represents the distance travelled in the period of t1 seconds. Okay, so from point, okay, give it name, from point P to point Q to point R to point F. Okay, so under the graph PQ, the area is the distance travelled in the period of t1 seconds. Okay, so here that's a triangle B. Okay, the triangle B is the area under the graph RS that represent the distance travelled in the period of t3 minus t2. Okay, here is t3 minus t2 seconds. Okay, let's say t3 is 8 and t2 is 4, so the time there is 8 minus 4 equals to 4 seconds. So the time taken is 4 seconds. How do we get the time taken? t3 minus t2, the final time minus the initial time. Okay, so the deceleration is actually the same as acceleration for the formula. Deceleration equals to the change of speed divided by the change in time as well. However, how does this two differ? Acceleration is when the gradient is positive. Here, positive gradient, and here is when you got the negative gradient. Okay, so let's try a simple example. Let's try example 14 from the textbook. Example 14, let's look at the textbook. Okay, example 14, example 14 here. Okay, the speed time graph shows the motion of one Salinas car for a period of 15 seconds. Calculate the rate of change of speed for the first 5 seconds. For the first 5 seconds here, you got to find the gradient. Next, describe the motion of the car for the second 5 seconds. So the motion, you have to talk about the speed and the time. Okay, for the 5 seconds, for the second 5 seconds. Okay, the second 5 seconds, 5 saat 5 saat yang kedua, macam tu, faham ni? The second 5 seconds, the first 5 seconds is the first 5 seconds lah. The second 5 seconds is from the saat ke-5 sampai saat ke-10. Okay, so the motion is the car moves at a uniform speed. Here uniform speed, okay, of 40 meter per second. 40 meter per second for the period of 5 seconds here. Okay, The last one, calculate the total distance in meters traveled in the period of 15 seconds. The total distance traveled meaning you have to calculate the whole area under the graph. So here you have trapezium, rectangle, and another trapezium. So you just add up the area and then you will get 600 meters. Oops, sorry. Okay, so area under the graph, the trapezium plus the rectangle plus the trapezium again, so we get 600 meters. Okay, so that's all for this subtopic. Thank you guys.